Good morning, friends. Myself, Richa. So, today I'm going to talk about Meselson and Stahl experiment, which concludes that DNA replication is semi-conservative. So, how did they do? They did an experiment in which they grew E. coli in N15 medium, and basically it is ammonium chloride NH4Cl, and they label the N with 15 isotope. So it is non-radioactive. Basically N15 is non-radioactive and it is a heavy isotope. That means if you subject this E. coli cells into NH4Cl medium in which the N is labeled with 15, so you will get the basically you will get here the heavy band that is of N15. And if you transfer this E. coli from N15 to N14, then you will get the lighter band, because N14 is little lighter. So you will get the little bit lighter because it is lighter isotope. So here you can see they did an experiment in which they used CaCl, that is cesium chloride density gradient. So plus here, and it is here you can see the -1. So here all the heavy bands will come, right? And as you go up in the fourth generation, you are getting more of lighter bands, that is N14. So first of all, they began by growing E. coli in medium which contains N15. When they grew on medium which contains N15, that is heavy nitrogen, the bacteria took up the nitrogen and it is used to synthesize new biological molecules including DNA. So after every generation you can see from 0 to 20 minutes. So E. coli, as we already know, it multiplies after every 20 minutes. So all the nitrogen bases of bacteria DNA were all labeled with N15. After few generations, after next generation, what they did, the bacteria will switch to a medium which contains N14 only, that is a lighter isotope. Then they allowed to grow for several generations in N14 medium. So what did they observe? You can see here. So in the first one, after 20 minutes, you can see here what you're getting. So this is the generation 0, right? So you can see a single band here, which is of N15 only, right? Because they grew the E. coli in N15. Next, in generation 2, after the 20 minutes it is getting, so it is getting doubled. So this is the first one. So here you are getting this 100% you are getting. Next, if you are getting the generation 2 here, after every 20 minutes the E. coli cells are getting doubled, so you will get 50-50 ratio, and 14-50 you are getting, and intermediate you will get 50%. So as you go higher, the time is getting consumed, so 40 to 60, 60 to 80, you will get more of N14. That is 88%. After 4th generation, you will get 88% of N14 and only 12% you will get of N15. So from this you can depict that Meselson and Stahl, that DNA it's getting replicated semi-conservatively, because you can see the pattern of 2 distinct bands, and the more generations here you can see, the more fainter bands, lighter bands are more as compared to the intermediate bands. Okay, so this proves this thing. So thus over the 3rd or 4th generations, we would expect the hybrid band to become progressively fainter. So it is getting fainter, hybrid band, and the light band to become progressively stronger. Here you can see 88% it's getting there. So it is a larger fraction, it's of 9-14. So this concludes that the experiment, the hypothesis was that might be it is a semi-conservative model they are following. So after doing this experiment, they Meselson and Stahl proved that the DNA replication is semi-conservative, because you are getting more of lighter bands as compared to the intermediate bands. So thank you. So in the CSIR NET exam, they will give you this diagram of various generations, and they will ask how much percentage you are getting in the fourth generation, or how much percentage you are getting after second generations of intermediate band and this light bands. So you can see after second generation, you will see 50-50 ratio. And after fourth one, you are getting 88 and 12%. 88% and 12% ratio. This is the most important question what CSIR exam asks for. So thank you. Have a nice day.